Hello everyone. Now we are going to discuss about the question adjacent increasing subarrays detection 2. If you didn't solve the first question, go and check the description. I have given the link in the of the first video. So the problem states that we are given with array of integers nums of length n. So now we need to find the element k, int k. So we need to return the k so that a k size of subarray, two adjacent subarrays are present in the array and they are strictly increasing. So let us take an example which is given in the Leetcode. 2 5 7 8 9 2 3 4 3 1. If we see 2 and 5, they are increasing, and 7 and 8 and then 9. But when we go to 2, it is not increasing. So let us break this loop and then go to 2 and then 3. They both are increasing, and then 4. And when we compare 4 with 3, they are not increasing. So break this loop and then 3. Then 1 is not increasing with respect to 3. So break the loop here. So we are having 4 subarrays which are strictly increasing. 3 and 1 are also increasing. 1 or 2 or any subarray which has only one element is strictly increasing because we don't have any other element to compare with. So here the size of this subarray is 5, and here the size of the subarray is 3. Here 1 and here 1. If we see 4 and 3 are subarrays which are strictly increasing, and 3 and 1 are also increasing subarrays, but the size of these subarrays is 1. And here 3. Here 2 5 7 8 9 are also increasing, and 2 3 4 is also increasing. If we consider only these 3 elements 7 8 9 with respect to 2 3 4, these both subarrays are adjacent and strictly increasing. So here the maximum count of these subarrays is 3, but whereas here is 1. When we compare 4 with subarray 4 and 3, we also get 1. But if we compare again 2 5 as a subarray and 7 8 as another subarray, we get count 2 here. But if we see all the subarrays, the maximum count we get is 3. If we go to the next example, 1 2 3 4 4 4 4 5 6 7. Here we have 1 to 2 is increasing, and 3 increasing, and 4. But when we go to another 4, it is not increasing because they said the subarray should be strictly increasing. So 4 and 4 are both equal, so we cannot say that they both are increasing. So, and then 4 and 4, they both are not increasing, so break the loop. 4 and 4, they are not strictly increasing, so break the loop. And 4, then 5, then 6, and then 7, these 4 are strictly increasing. This is a subarray, and this is the another subarray, this is the another subarray, and this is another subarray. If we compare this subarray with this subarray, we get the maximum count k as 1. And if we compare this both subarrays, we get 1. If we compare this both, we get 1. But if we compare the subarray or split this subarray into 2, we get the count of 2. We get the count of 2, and these two subarrays are strictly increasing. So the maximum count here is 2 compared to ones. And if we compare this with the another two subarrays, in 4 5 6 7, these two are also strictly increasing. So the size of these two subarrays is 2, and these two subarrays are adjacent. So we need to be remember the point that they should be adjacent and strictly increasing, and also the count of the size should be maximum. So if we go to the algorithm, we initialize previous, current. So previous is for the previous subarray size, and current is for the current subarray which is strictly increasing. They both are adjacent subarrays, and also we initialize maximum count which we need to return as 1. So if we take 9, 8, 7 as an array, we have 9 as a subarray, 8 as a subarray, and 7 as a subarray. They all have the count or size as 1. So there will be no array which doesn't have maximum count less than 1. So every array will be having maximum count or k as 1. So we are initializing maximum count as 1. Then we need to iterate the array from index is equal to 1 to n. So while index is less than n, now if the current if the index if the number at the current index is greater than the number at the previous index, we increment the count. So nums of index is greater than nums of index minus 1, then we increment the current. If it is not possible, if it is breaking the loop, then we make previous is equal to current and current is equal to 1, as the current will be coming from 1 here. The count will be 5, and then we will be starting from 1 here, and then we need to check two constraints here. If previous is equal to current, for example, if we have 1 2 3 1 2 5 4 5 6, here the previous is 3 and current is 3. These both are having the same count of previous and current, so we can make sure that 3 is the maximum count. So maximum count is equal to maximum of maximum count comma current. You can also place previous here, or else if we have previous is not equal to current, then we need to check two constraints here. If we have 6 as the previous and 14 as the current, if we take minimum from these two, we have 6 here, we get 6 as the maximum count. But if we split the 14 as 2, we get 7 and 7, then we get a subarray which is greater than the size of 6. So 7 will be the maximum count here. So we need to again consider the maximum of current by 2 comma previous by 2. So I am again initializing max c is equal to maximum of a comma b, and then maximum count is equal to maximum of maximum count comma max c, and then index increment the index. After this while loop, we can return the maximum count. Thank you.